Good morning, good afternoon, and good evening, everyone. I hope you are all doing well and staying safe. Here is Mariam Shref, a petroleum engineer from Lebanon, and it's a great pleasure for me to introduce our distinguished guest speaker, Dr. Muhammad ثروت Hassan. He is the Egyptian scientist who developed the light field synthesizer to generate the first optical attosecond pulse, the shortest light pulse documented in the Guinness World Records. Currently, Dr. Hassan is a professor of physics and optical sciences at the University of Arizona in the United States. He is known for developing the attosecond electron microscopy and the attosecond electron diffraction to image the electron dynamics of matter in real time and space. He has a US patent for his attomicroscopy, attosecond electron imaging, and microscopy. His research aims to image record moves of electrons in action. In 2019, Dr. Hassan received the Air Force's Young Investigator Award. And finally, he holds a Bachelor of Science in Chemistry from Cairo University, a master's degree from the National Institute of Laser Science, Cairo University, and a PhD in the attosecond physics from the Max Planck Institute for Quantum Optics. So please join me in welcoming Dr. Hassan. So welcome, Doctor, and we are pleasured having you with us today.
Thank you, Mariam, for the nice introduction. It's my pleasure to be with you today.
Thank you. And as a reminder, if you have any question to Dr. Hassan, please drop it down in the Q&A section, and we will try to answer your questions at the end of the webinar. So let me begin by asking you, Doctor. So where was your high school, and what did you dream of becoming when you were a child?
So I was born in a city called Al Fayoum. It's like 100 kilometers far from the capital city, Cairo. So I went to the high school in the same city in 1999. And when I was a child, I was always try to think in the big challenges stuff. So I like mathematics, I like physics, I like chemistry so much when I was in the high school. And this is, I think, was a driving force for me to join the Faculty of Science later on.
So, Doctor, why did you choose your field of study? So what drew you into this field?
Okay, so in 1999, it was a coincidence that as the first Egyptian scientist to get a Nobel Prize in chemistry in 1999, Dr. Ahmad Zweil, and was a big motivation for, I think, the entire generation. So when I joined, this is why actually I decided to go to the chemistry department in the Faculty of Science, because it was the same year I joined the university or started my university study. So I started the study by studying chemistry in my bachelor. However, I was fascinated with electron dynamics and the electron motion from the basic physical chemistry lectures we studied in the Faculty of Science. So I was all the time wondering how these electrons move. Why it moves in this way is not moving in that way. So this is built in a sort of passion, scientific passion inside me about the electron motion. Then I learned during my bachelor degree that the electron motion is really directly connected to the laser science. The laser is the driver for the electron motion. So this is why I decided after the bachelor degree to study lasers, because if you would like to know about the electrons, you would like to know also about the electron driver. And the electron driver is the laser. So I studied my master's degree in the National Institute of Laser Sciences in Cairo University, where I started to study some principles about the laser before joining the Max Planck which was, I think, a turning point in my career. So my passion about science and about electron dynamics and about electron motion, all of this started when I was in my undergrad study in the Faculty of Science.
So, was there any quote that motivated you as a student back then?
I mean, the curiosity. It was the first or the biggest driving force for me. I was always curious to understand more. And this is actually why it makes me jump between chemistry and physics, because it's a very interesting discipline, field of study, because you would like to understand how is the electron are moving using the physics to apply this in the chemical reaction. So it was a combination of both of them. So this started when I was young, very young. I didn't know that my entire career would be related to what I studied in the undergrad, or what makes me curious about the scientific problems in my undergrad. It turns out to be the story of my career life.
So, what dreams and goals did you have for your career when you graduated, and were you able to achieve these goals?
Usually, the good scientist does not have an fixed aims or goals. He may have a big dream he wants to reach, but happens by setting in a certain objectives or certain goals during your career path, starting when you are undergrad student, reaching to the level when you become a very well-known scientist. So my goals change from time to time based on my career stage. So when I was an undergrad, my goal was to learn more and learn more from a very good institution in a very good group. So I was able to acquire a high level of scientific knowledge in this group. So when I was an undergrad, my dream was to become a professor one day, and this changed later on. When I finishes my PhD, I'm just giving you an example how the goals are changing from stage to stage in your career life. So in the beginning, I wanted to be a professor when I was an undergrad student. Then when I joined Max Planck and I got my PhD, I don't want it to be anymore as a professor. I wanted to be a very well-known professor for something. I am changing in science. So this is what I'm talking about, flexibility of objectives. But achieving a position or achieving a scientific position is not dream. It's just a goal. The dreams are always different than goals. So goals is changing from stage to stage in your career. Dreams never change. It's a one big dream, and you take it step by step until you realize your dream and makes it true. So my scientific dream is to be the one who is imaging the electron motion. This is a small, tiny movement inside the atoms, which is controlling our life. This is one of the most important secrets in our life, the electron motion. I wanted to be known for the one who able to provide the humankind the first video and images of this unseen electron motion inside the matter. And I'm sure will open a new avenues in different fields of science, chemistry, physics, biology. This is a big dream. How I achieve it? By setting a certain goals. First, undergrad, I was aiming to get the best scientific knowledge during my PhD. When I finished my PhD, I moved these goals to be not just doing a small contribution in the scientific field, but rather an important, significant contribution. So there are goals and there are dreams. They are different, But the goals is the later steps takes you to realize your dreams.
Can you tell us more about your research work?
Yeah, so when I started in the beginning, the real start was during my PhD. And during my PhD, I was able to develop the light field synthesizer. This is a small device which can control the shape of the laser waveforms. We all know that people here are mostly engineers. They know what is the waveform means, either sine or cosine waveform, right? So particularly for the electromagnetic waveforms, laser waveforms. I developed this synthesizer to control the shape of this waveform. But the controlling was not the final aim. The final aim was to use this controlled waveform to control the electron motion. So this is what I have done in my PhD, and I was using this waveform to control the electron motion inside krypton atoms. And I was able, for the first time, to measure how long the electrons takes to excited from the ground state to the excited state. All of the people here, I am sure they studied during their high schools or during their undergrad study, whatever your degree, engineering or science or whatsoever, if it's in the scientific direction, when you excite the electrons from the ground state or give it some energy, it excites to the excited state. But nobody ever was able to measure the time it takes for this excitation to happen. This is what I did during my PhD for krypton atoms, and this turns out to be 100 attoseconds. And this is published in Nature in 2016. Later on, when I started my postdoc study, I tried to combine what I have learned in attosecond physics in Max Planck. I joined Caltech to Ahmed Zweil group again, and it looks like our destiny is connected. And there in his group, they were developing the 4D ultra-fast electron microscope to image the atomic motion. But this happens in few hundred femtosecond time scale. So they would try to see the atomic motion. Now when I went to there, I tried to combine what I have learned in my PhD and implemented the attosecond resolution inside the microscope, aiming to reach my dream of imaging the electron motion. So for that, I developed also a new approach and a new technique to enhance the temporal resolution inside the electron microscope from 500 femtosecond, which is the typical temporal resolution. I enhanced it 16 times better to be 30 femtosecond, and this was the first step to achieve my goal by reaching the attosecond resolution in the electron microscope for imaging, or converted this microscope to an electron camera. So after that, there's also a paper published in Nature Photonics in 2017, and then when I started my own group, I was building everything based on my previous, or not previous, my dream to convert it to an electron camera. So currently now we developed the attosecond laser pulses, which we used recently to control the electron motion inside a dielectric material, namely glass. And by controlling this electron motion using the attosecond laser pulses, we're able to control the properties of the material and convert this dielectric to a conductor, which has a huge application for the electronics in the future. And this is a paper which recently published also in Nature Photonics. The current direction is now to enhance the temporal resolution from 30 femtosecond I demonstrated in 2017 to reach less than 1 femtosecond or attosecond time scale. Then we will use this new resolution to capture images of the electrons.
So Dr. Hassan's research findings can increase the speed of electronic devices 100 million times, which will make a breakthrough in the transmission of information and communication between distant places. So do you think this breakthrough can happen in the next 10 to 15 years?
Indeed. So if we take a look to the developing rate of the technology over the last 20 years, it's huge. It's different than any time in the humankind history. So this rate of development of technology is really actually scary. I mean, in 20 years, you didn't have a phone, or some people they didn't have a computers in their homes. Now, I'm not telling you everybody has a computer at home. Everybody has a computer in his hand, right? So if you can think about it, particularly for the new generation, they didn't see the era before the cell phones or the era before the computers. They will not recognize how fast the technology is developing now. Based on this history of technology development in the last 20 years, I will not be surprised if this even happens faster than 10 years. Could happen in between 5-7 years. We may start to see the optical electronics, which is based on laser science and transferring information with attosecond speed.
So can you describe your experience working with Dr. Ahmad Zweil? For those who don't know, Dr. Zweil is known as the father of femtochemistry, and he was awarded the 1999 Nobel Prize in chemistry for his work on femtochemistry. So what have you learned from him, and what advice has he given you?
So I was fortunate to work with Dr. Zweil in his last few years, and it was a very enrichment experience. Working with him, and the people surprised when I tell this. I was coming from the attosecond field, going to him, learn about the ultra-fast electron microscope. But what I learned from Ahmed Zweil mostly was not scientific only. So I think what I learned from him is the experience of life, from his experience of life, more than his scientific achievement in life. So I learned from him how to be a visionary scientist, how to have a big vision, not just a small vision or small dreams or small goals. Should be a visionary, and a lot of people will not believe your dream, or they will not believe your vision, but you have to be confident about what you wanted to do and about your capability of doing it. So this is a big thing, because if you would like me to describe Ahmed Zweil in one word, I would not say a great scientist. Maybe you will be surprised, or the audience would be surprised, but I will not say this is as a word I describe him. He was definitely a great scientist, but this is not how I saw him, only as a great scientist, but I saw him as a visionary man, which I think one of the recipe of success, more than just to be a great scientist. There are a lot of great scientists in the global or in the scientific history, but there are really few visionary men.
So what are the main challenges that you have faced during your career?
Oh, many. So the situation or the career path, or as I would like to call it, the quest, was not just a smooth way taking you from one goal to the other. Rather, it was a very rough path to achieve my goals, scientific goals. So the first challenge is that big movement I did after I finished my master's to Max Planck. Now I'm coming with a master's degree. My knowledge about lasers is very limited. It was very limited, and I didn't know so much about that. And suddenly, I am in one of the biggest institutions in the world, and in a leading group for the attosecond laser science. Was a big shock, and the first challenge was to at least reach to the knowledge and experience level of your colleagues in the same lab, because everybody see you as a newcomer who does not know a lot of things, which was true, in fact. And now back to the time I had to double my effort and my work. First, to gain experience similar to what they have, and to study more to gain knowledge similar at least to what they have. It's like you are going for a running race, where your competitor or your colleagues next to you, they already finished their seventh lab and you are in your first one. And it's like 10 labs. So you have a very limited time to catch up with them. Was a very big challenge in my career, but I was able to overcome this challenge by a lot of hard work and spirit of not giving up. So I was pushing myself too hard until I reached to the level to be similar or better than my colleague in the same group. Was one of the biggest challenges in my career. This turned from master to PhD in one of the biggest institutions. Then later on, after I finished during my postdoc, I have my supervisor in my PhD is very well known in the attosecond physics. I'm expecting he will get a Nobel Prize in the next few years. And also, I am doing my postdoc with Ahmed Zweil, who got a Nobel Prize in 1999. Now, the big challenge was to find your new way, so that people will not always say he is following the step of his former supervisor in PhD or his supervisor in postdoc. So finding your dream, finding your vision, this was a big challenge, which took me a while to understand what's going on around me and what is the people are doing and what is the best path to go in the future to be unique and different than the others. Because here you are not competing with your colleagues in the same group anymore. You are competing with everybody in the field. And as I told you before, I didn't want it to be a researcher. I want to be the researcher of this field. So this was a big challenge as well. But I found my passion and my dream in imaging the electron motion. Then starting my group, and this comes as the normal challenges of professors when they started their own groups. And this is the normal challenges which everybody is facing. But I was focusing more here in the answering your question about the challenges, which is unique to me, which is not everybody is facing. And the challenges continue in your career path or to reach your scientific career. I think the biggest challenge is to see the electron. Nobody sees this before. You are doing something nobody did before, and you are not following certain guides or have any tips. You are making the steps. You are making this new path. So making new paths in life, it's hard and it's very challenging, but I have a strong belief I will make it.
Very inspiring, Doctor. So what achievements are you most proud of, and what has been your biggest success factor?
My biggest success factor, I will start with this part of the question, is never give up, because I choose by myself, not by destiny. I choose by myself to go the hard way, not the easy way. So that requires a lot of strength and a lot of potential to never give up, because you will face a lot of problems. Always, if you ask me this question, what is the biggest achievement you are proud of 10 years ago? And if you ask me this question today, and you will ask me this question in 10 years, in the next 10 years, or after 10 years from now, the answer will be the same. My biggest success never happened yet.
Okay, so in your opinion, what skills should someone in your field have?
I think in the scientific field, I will talk about more about the scientific field. All the successful people I have met in my life, they have a common thing. All of them, they have defined goals and aims for their lives. They are not going every morning their work to just do the work and go back home. They are going every day in the morning to take one step further to achieve their goals. So the first thing is to have a defined goals and to have a big dream later on. And the goals, as we said before, is your steps to achieve your dreams. The second thing, as I said it and I will say it again, the things is not coming by just mention it to yourself. Tomorrow I will make my dream true. Tomorrow I will make, no, you have to work and work very hard to achieve your goal. And the life will never be easy on you. So you have to expect that, and you should not, this is a certain point, should never ever give up whatsoever.
So what advice do you have for students and young professionals who are tuning in today?
So the things, I mean, or the career path becomes very difficult from day to day. So you have to be persisting. So you have to work hard. You should never give up, and you should distance yourself from the people that didn't believe in you, or they try to tell you you will never make it. This is so hard. Definitely, if it's easy, everybody can do it. But because it's hard, it meant only for the successful people. So if you find people around you not encourage you, distance yourself from them. Focus on your dream, focus on your goals only. Don't listen to somebody else unless this somebody is believing in you, in your goals, and helping you to reach them.
So we have a question from the audience. So could you please tell us how to build, how did you build this confidence about your dreams? So what motivated you?
So the confidence you build by success. So each step you are taking, each successful step you are taking in your life, even if it's a small step or even it's a small success, it increases your confidence about yourself. Particularly if the success you planned for or you aimed for from the beginning. You don't have to aim very high in the beginning. You should aim too high every step, higher than before. So the confidence comes with the success. You are never give up. You are doing this success, takes you to the next step. You build more confidence about yourself, and so on until you reach to your goal.
Okay, thank you, Doctor, for answering our questions and experience and your research about controlling the electron motion in an attosecond timescale. And it was an honor having you with us today. And of course, we look forward to having you in our future events.
Thank you so much for having me. It was a pleasure to be with you and with Dr. Ahmad and the audience. Thank you so much for having me.